Hello, let's talk about a messenger app, a system design interview question, where we may need to design a system similar to like WhatsApp, Facebook Messenger, or like Viber. Let's go through the topics real quick. As always, starting with clarifying questions and requirements, then high-level design, and choosing databases, online status, and group chats. So clarifying questions and requirements would be like a lot, and it's probably like ways to like make this problem like take a really long time. So we'll need to like pick some core functionalities and limit some others. Like even for example, if we support one-on-one chats or group chats as well. What kind of messages do we support? Like text, photos, and videos. I would be mostly covering text, but for photos and videos, you can just add some sort of object storage, like at S3 from AWS. Then what should be delivery guarantees and latency? Generally, it should be like likely exactly once. Well, we can like probably leave with at least once and then like deduplicate on the client application. And latency should be like real quick, maybe within like seconds, or like maybe less than 1 second even. How do you identify user? Phone number, email, or username? There could be like different approaches. We can probably pick a phone number, but like pretty much any form of identifier like works. Do we support online status? Yes, we probably will. Do we have to search past messages? Yes, we will have to. Do messages persist forever or gone after some time? We'll consider cases where they persist forever, although there would be some simplifications if they're always gone after some time. But then like it would be a bit more complex if they can be gone after a certain amount of time, but most messages are persisted. Are messages end-to-end encrypted? For now, we'll consider that not, because end-to-end encryption is like a very difficult topic, especially with like group chats. Is how to exchange the tokens, and also we probably want some option for a cloud backup. Do we support mobile push notifications? I'd say yes, and we're gonna briefly talk about this. Do we have read receipts? And also I'd say yes. So let's go to high-level components. So we have users, they go through like load balancer to API gateway, and then there are like multiple services. And many of them are coupled with some DBs or indexes. One is messages service, which processes incoming messages and like returns new messages. And there is a messages DB, which stores them. There is a search service, which uses some search indexes, and it's based on DB. Alternatively, you can have some sort of like message queue like Kafka. When new messages come in, and maybe like multiple consumers read through it. Like one can put messages just to DB, another can put it to the search index. Then there is online service. You'll need a separate thing for that, and online status DB, and potentially contact service and contacts DB. This may be stored on only on the like users' devices, but it's good to have some form of persistence for some applications. So it depends on like what exactly you're asked to implement. And then there is a push notification service. It's gonna use some APIs provided by Google or Apple, and both online and messages service can like probably send some notifications, mostly like messages service. Online, you probably want to send some updates, but most likely you don't want them as like push notifications, except if you like you directly subscribe to this. So let's go to choosing databases. For messages DB, you need fast access, high durability, and some form of compression for all their data, because otherwise it's just gonna be like much more expensive, and like all data is often like not as needed for messages. And one option can be HBase, which is designed for this kind of like messages storing. And you can like do some like manual things yourself. We just have like multiple layers of DB and transition data between them. But generally choosing some existing solution is like a better idea. But generally you can have some idea of like hot storage, warm storage, and cold storage with like different costs and different guarantees of how things are done. It all depends also on like requirements you have. For example, if you really don't really need to like search past messages after like certain time, or it's okay to like maybe request messages and then not have an infinite scroll, then you can like have like very cheap things like maybe S3 Glacier or something. But in most cases you would want some more like user-friendly thing, maybe Glacier Instant Retrieval or something like that. For like cold storage. For warm storage, yeah, probably something like S3 may be fine if you like, again, if you design it yourself. And for hot storage, just have some in-memory databases with some like backups on disk, or maybe just like use RDS. Have some jobs which transition data. Then there is ContextDB, needs high durability and consistency, and relational database is like likely a good fit. Online status DB. This needs to be high performance and have a high availability. Durability is not as important because people are gonna send online status pretty often. So if you lose one message, we can just like regain it like sometime later, like real quick. KeyValue stores like Redis can be a good fit. Search indexes need high performance, flexible query engine. Dedicated systems like OpenSearch can be a good fit, or you can use like Leaf Aggregator Tailor system to like index messages yourself and like just search by a word and rank results somehow. Maybe like by how many words from your search query have matched. Okay, if you're using AND query, or you can combine with like some OR queries. It all depends on the requirements. So like search is like by itself is pretty big topic. So that's something you can choose to deep dive into if you have like more knowledge of like prepared better for this, specifically for like search questions. But for the purposes of this talk, I'm gonna leave it as more like high level entry. Online status should be handled separately from messages by sending users periodically sending heartbeats to the servers. It's probably going to be some long polling connections, or maybe you can use WebSockets as well. Alternatively, since for heartbeats, sending heartbeats, we can just do a regular HTTP request, but also have long polling connections or WebSockets only for like retrieving the updates from other people when they come online. We can also like use some form of a push. If you have like WebSockets, for example, we can notify all contacts about the status changes if it's persistent. For example, we don't want to spam people when the network is spotty. And then status can be stored as in a key value store, key being some form of user ID, like a phone number, for example, and value would be last online timestamp. And that can be also expiration TTL to strike some balance between like providing value and like saving some cost. Also, data is pretty small, so like likely it's not as critical to have this TTL. So you can choose to just like keep it and like maybe then you can have messages, hey, somebody was online maybe like 1 month ago or something like that. And let's talk about group chats. They're more complex due to need to deliver updates to more people, and that's why we typically want to have relatively small limit on the number of people in the group chat, maybe like 50 or 100. We're not trying to design a system like Slack where there can be like a ton of people in each channel. And we're like trying to be like more real time and more like performant. And just essentially we're gonna have some like databases which like link chat ID to some associated messages. And then like link users to like chat they're part of, and basically have some form of for loops when like message needs to be delivered. Online status for a group chat can be based on aggregation of individual user statuses. So like again, like it's something where we can use basically a for loop over the data. And read receipts become in the form of like maps from each user's last message they've read. That there can be essentially like a separate message to be delivered. When somebody reads it, we initiate some like essentially a ping that, hey, user X read this message, read those messages, or at least now this is the last message they've read or something like that. And we send this to all users in a chat. In case of one-on-one chat, it's basically like essentially a case when a group chat of 2 people. You can think of it this way. This is going to simplify the architecture. But of course, if you have to design a system for like only one-on-one chats, it offers more flexibility in how you can design it. And also like can offer more options basically. But yeah, that's gonna be it. Thanks for watching.